Hey team, it's John. You're on the JRB Tree Climbing channel. JRB Tree Climbing is also the name of my Facebook group, my Patreon, and my website. Recently, I had a video introducing you to an original creation, the Longhorn Hitch and Soft Shackle. And this is a knot tying video on it. We also did some strength testing since that initial video. You can find that on my channel, where we found that a 7mm length of sterling cord with an MBS of 2787, we pulled and broke that a number of times, and surprisingly, this hitch is amazingly efficient. When we pulled this apparatus from end to end, we got an MBS of 5419 or 24 kilonewtons. Now there's only 5 samples in that set, and we were conservative in estimating our 3 sigma breaking strength. But the bottom line is that right now, if I pulled this to failure, I've got a carabiner rated at 24 kilonewtons, and I've got this. I don't know what's going to break first, the carabiner or this apparatus. So it's quite strong. And you'll recall from the other video, we transformed this into a soft shackle by taking the bite through the end, and we got varying ways to close that. That would be one way with a hard toggle, and there's multiple ways we can close this end in the soft form, the easiest being just taking the 2 strands and putting it through. So once we can tie the hitch, we can tie the soft shackle. So we're going to get on with that, and we're going to tie it both what I call right side up and upside down. In upside down form, you've already seen me demonstrate how the Longhorn hitch can be used in conjunction with a friction hitch. It's such that if we tie it really close, it becomes effectively a hand ascender and an auto tending device, and this will work for basically any friction hitch. But we've got to be able to tie it well and tie it upside down. So let's go ahead and tie it. I've got a 6-foot length of that sterling cord, and I'll be tying it on the bar. So I will basically take this and fold it in half and fold it in half again. So I've got it in 4 equal segments. And you know, the exact length might vary for your application, but I'm going to put it over, and I've got the loop in the front and the working ends in the back, and we're going to tie the hitch. So we'll start by taking the working end, and I'll start on the right. It could be the left. I'll take the one on the right, and I will bring it over and around the front and back where it started, 360 degrees around. I'll now repeat that process with the one on the left. And note how this strand is going over and in between the starting strand, so that they are interlocked, right? They are interlocked. What I did not do is this. I didn't do that where they are not interlocked. Start over. One on the right goes around 360 degrees. One on the left goes around and interlocks and goes over that strand 360 degrees. Now, this is the over strand, the one on the left. So I'm going to keep working with that, and I'll take it up and along the host. Now I'll take the one on the right, and I will go up and over that strand, so closer to the host. I'm using terms that'll work when we're upside down, because we want to give this strand a chance to be the over strand. We're alternating the over-under pattern. So at this stage in the hitch's development, both of these 2 strands have switched sides twice and are on the opposite side of where they started, and both of them have gone over themselves and the other strand one time. And lastly, to complete the hitch, I take the 2 working ends and I bring them back up through in this fashion. And we'll dive in even a little closer now to watch that action. So the strands, it's important to remember that the strands are always headed towards the host. when you're tying this upside down, there might be an inclination. You forget which way to go and you're going towards the loop. You never go towards the loop. You always go towards the host. So that's the completed hitch. And I always leave nice, long, healthy tails. Now, if we were to load this significantly, a little bit, a little slack would come out. So I'm actually going to interrupt your field of view here and put my body weight on this to show you that and how we dress it after load. So I had 90% of my body weight on there, and you can see it's morphed just a little bit. And these strands, we'll be able to pull just a little bit of slack out of those, just a little bit of slack to get it set. Now, under the weight of our body, I've never had any difficulty in releasing the hitch. Now here on this bar, of course, I can't slide the bar off of the end. And so all we do to remove the hitch is we'll remove the host if possible, and then slide the end through, and now it's got plenty of room to be untied. If you happen to tie it onto a fixed host like this and you use it for rigging or something like that, and you need to get it off, well, under a significant load, the nice thing is that you can take a flat blade screwdriver and put it on the outside strands, and you can break that pretty reliably. Okay, now let's repeat this, and let's tie it in the form of basically upside down, and I'll be doing it as compact as possible. Let's repeat that. This application now could be any friction hitch in the world. You've seen my video on how to build the head-in hand ascender. Well, that technique works on any friction hitch. So here's an experimental friction hitch that I'm working on. It doesn't even matter what that hitch is, but I want to turn it into an auto-tending hand ascender. So I'll be doing that with a carabiner, and what I'll do is I'll start by putting the carabiner on the line. Now it'd be a little easier if I was tying it down here, but I'll be tying it up as close and compact to the friction hitch as possible. So how do we do it? Well, everything is exactly the same. It's just that we're doing it upside down relative to what you saw a moment ago, and effectively just very compact. It's very compact, so we don't have a lot of extra room to work with. So I take my two working ends, place them over the host, and again, I'll start with the one on the right, and I go around 360 degrees. But I don't want to capture the other strand, right? I got to duck that out of the way. So I've got that around 360 degrees. Now I'll take the one on the left, and I'll do the same. Take it around the front, and I go over the other working end and make sure they interlock and take it around 360 degrees. So that's the initial stage. Now, still working with the strand on the left, I go along the host. A little bit of, I'm making this as compact as I possibly can. Slack always seems to show up when we load it. So we're intentionally making this uncomfortably tight. I pass that along the host. Take the other working end and place it along the host. Where do I do it? Here or there? No, I want to be the over strand. So I take it up, I should say down, relative to the other strand, such that when we finish it, it will be the over strand. And lastly, these two will come down through here. Now, if I was using the nail, I could make this a little bit stay out of your field of view, but I want it to be realistic. I never need the nail in practice. I just use a little bit of finger strength to open that up a little bit. Pull this down. And so this is just a test, right? I'm still trying out a new friction hitch, and I didn't really take my time to get my tails perfectly. The lengths are different, and if I liked the performance of this, I could retie it, or if I was comfortable with a tail, and I do like to have a long tail on these, then I could just trim this one off. But let's go ahead and load that. And, you know, again, as I load everything here in this contraption, you know, a little bit of slack will show up here. So I dress that out, pulling on the ends. Okay, so it's loaded and it's set. Now let's just engage it as a hand ascender. Well, how do we do that? We'll get a little bit of room because these two ends slide through. Let's remove my carabiner. And I take the two loops at the bottom and widen them and go around the rope. When I have it in that fashion, take the carabiner and I encapsulate both of the loops on the bottom and the rope itself. And now I've transformed that experimental friction hitch into a hand ascender. I could climb on that, and if I was using it, let's say a tether application, I can auto tend slack out here. See what's happening? The Longhorn, as I goes up and tends the friction hitch up. Okay, well, hopefully that'll give you the detail you need to tie the Longhorn hitch, both what I call right side up and upside down, and turn any friction hitch into an auto tending device or a crude hand ascender. Thank you very much.